The first question, the definition and the simple properties of the example of stochastic process. First one is Poisson process. The definition goes like this. The mean value is nt equal to lambda t. Autocorrelation function equals to rt1 t2 equals to lambda square t1 t2 plus lambda mean t1 t2. Definition goes like x0 equals to 0 and xt1 minus xt2 equals to the number of calls received in t2 t1 with this the probability. The Poisson increment definition with xt, a Poisson process defined above, and epsilon bigger than 0, a given constant, we construct a new process yt equals to xt plus epsilon minus xt over epsilon. The mean value is eta t equals to yt mean value, and goes like the result is lambda. The autocorrelation value goes like when t1 minus t2 absolute bigger than epsilon, the value is lambda square, or the value is lambda square plus lambda over epsilon minus lambda multiple with t1 minus t2 over epsilon square. The Poisson impulses goes like the definition is defined a stochastic process zt as follows. Zt equals to the derivative of xt is limited yt when epsilon equals to 0. The mean value is lambda. The autocorrelation goes to lambda square plus lambda multiple with t1 minus t2. The semi-random telegraph signal definition is if x0 is a fixed one, then we call it a semi-random telegraph. The stochastic process is defined as follows. When k is even in 0 to t, the value is 1. When k is odd in 0 to t, the value is minus 1. Probability mass equals to when x equals to 1, the probability goes like here. When x equals to minus 1, the probability goes like this. The mean value, which is eta t equals to exponential minus 2 lambda t. Autocorrelation should be when t1 bigger than t2. Autocorrelation goes to this. When t1 smaller than t2, autocorrelation goes like this. Therefore, autocorrelation is here. Another random telegraph signal. Definition of random telegraph signal is let A be a random variable independent of xt with A equals to 1 probability equal to when A equals to minus 1, the probability equals to the 1 over 2. If x0 is a random variable taking 1 or minus 1, then we call it a random telegraph. We form a new process, yt equals to A multiple with xt. Then yt is the random telegraph signal. When k is even in 0t, it's 1. So the probability mass goes like this. It's the constant half. And when yt equals to -1, the probability is 1/2. Mean value should be eta t equals to 0. EA equals to 0. Autocorrelation RT1, T2 equals to this, because the mean value of A squared should be 1, so autocorrelation value should be like this. Random walk. The definition of random walk is tossing of a fire coin infinite times, and it should be xt equals to xnt. The probability mass when xnt equals to rs, the probability equals to this. The mean value should be 0. Autocorrelation should be minimum value of n and m multiplied with s squared. Wiener process. Define Wiener process as a limiting process of random walk. Wt equals to limit xt s equals to 0, t equals to 0, n equals to infinite. Density f omega t equals to 1/2 plus ERF multiplied with W over square alpha t. The probability density function goes like this. Mean value is 0. Autocorrelation is this. Explain the understanding of those processes. First is Poisson distribution. Nt equals to lambda t, while the longer time span the protected number of buses is larger. Poisson increments. Nt is not related. Poisson impulse. Nt is not related to t. It's a constant. Semi-random telephone signal with the increment of t, eta t will be decreasing. Second, WSS process. Definition: a stochastic process is called WSS process if Nt equals to constant. In our autocorrelation only related with T1 minus T2. Independent increment process. We say that xt is a process with independent increments if the probability goes like this for any non-overlapping intervals. Markov process. We say that the process xt is a Markov process if the past has no influence on the statistics of the future under the condition that the present is known. For any n and T1 bigger than T2 bigger than Tn, we have the probability goes like this. Normal process. A process xt is said to be normal if the random variables xt1, xt2, xtn are jointly normal for any n, any T1, T2, Tn. The nth density function should be this. SSS process. We say that real statistic process xt is stationary in strict sense if its statistics is not affected by a shift on the time axis. Xt is SSS if the probability density function equals to this. For any n, any T1, T2, Tn, and any epsilon. White noise. Definition: Yt is a zero mean white noise if RW T1 T2 equals to QT1 T1 minus T2. Mean ergodic process. X is said to be mean ergodic if the equation satisfied. As the cascade process set is called ergodic if all its statistics can be determined from a single sample.